This is really cool stuff. So there's another process that uses essentially a combination of powders and liquid droplets as glue. That's developed by a company called Z-Corp. There are other technologies that are coming out. Most recently, there was one that was announced by XJet, another one that's in the works by Desktop Metal, to use ink jetting of either metals or plastics themselves that are UV curable, very much like Stratasys' object line of machines does. They take a material, they ink jet it. That material, once it's on the surface, is a liquid, and then when they expose it to a certain wavelength of light, it hardens. And then in the case of XJet, it does something very similar, except they have to put it into a furnace afterwards, and then you get a metal part. The reason I have this here is to show you the imprecision of this process. You can see here they've got trailing droplets. What they wanted was this droplet, and what they ended up with was all this crap behind it too. So it's a very difficult process to control at a micro scale, but I'll show you a slow-mo video of it happening. Look at that. And then it forms a second droplet there, and a third one trails, right? And then look at this thing, it's like oscillating back and forth up here. That's not what you want. I'll play it again. So pay attention right here. Okay, one droplet passed, another droplet formed, and then the third one there. And then look at this thing. It's not a very precise process. And this is with a stationary inkjet head. If this inkjet head was accelerating back and forth, that trail would also be accelerating and lagging behind it. This video is really cool. It shows you the impact of a droplet. So pay close attention to the oscillation. It hits, it bulbs up, it's like pancake flat, it bulbs up, oscillates back down, and then eventually comes back up slightly. Again, this kind of shows you the imprecision of the process. Everything's moving around. If you're trying to melt metal like that, and the metal cooled down too quickly, it wouldn't have enough time to fully dampen and oscillate. It would just freeze in that position. And you don't know what position it froze in because you really don't have control over how much precise heat got deposited. And more importantly, the distance between the nozzle and where you're trying to print drastically impacts the dynamics of that inkjet droplet, both in terms of the trail and then as well in terms of the impact.